So yesterday we talked about match expression, how the match expression works, what, and also we talked about for expression, how normally a for loop is being used, and how it is being used in Scala. In Scala, it is used in both mutability form and immutability form as well. We saw both the examples. So mutability is as usual, just modification you want to do, you use the for loop. In case of immutability, it takes a collection and returns a collection where each element of the collection is modified according to the logic in the body of the for expression. Or whatever logic you give in the for expression, that logic will be applied on every element, and a new element is created, and finally a new collection is created. So we saw that for yield. And I also said that internally there is, most of the time we don't use for yield. There is a function called map function. That function will be using more and more. Similarly, we saw for yield and iterator guard. Iterator guard is just a if condition. So that we use to filter out some records. That logic will be applied on every record. If the logic is true, then that record will be collected in the destination record. If the logic is false, then the record will not be collected in the destination record. So we use its filter function. Most of the time we don't use for yield with iterator guard. Most of the time we solve the problem using a filter function. We will be seeing these functions as well. To understand those functions, we need to learn some more things about the functions. So we saw that these examples, right? I mean to say, so this is what we declared. This is user 2. So I'm just searching in the history. Yesterday I had typed all this command, Control R, and search in the history. So if you remember, we had yesterday declared users, or it would be better to say as I was talking about employees. There are three employees here, and array is just like a collection. Array is a collection. It is just like a table, you can assume, where three records are there. Here we have three elements. All the three elements are tuple elements. So based on any transformation, if you want to do, we can use for and yield. Any filtering you want to do, we can use for, yield, and iterator guard. So yesterday we saw, well, I want only the age, name and age. I can just say val name age equal to, I can use a for expression. Each element take from employees employees and just return I dot underscore 2 and I dot underscore 3. Okay. I did not use the yield keyword. As you can see, if you don't use the yield keyword, the for expression does not return anything. Now we can see that we got a one more collection with only name and age. And also yesterday we saw how we can use the iterator guard. I can just say if I I is each tuple dot underscore 3 will give the age. I can check give me all the age which is greater than all the records which is where age is greater than 30, and I can just say yield I. This way you can see that I only get two records. I only get two records. So this is what I call as a iterator guard. A condition, if condition, just like we had in our match expression. Now what will be the result? There is a slight change now. Now if I put the same result, instead of writing the iterator guard, I will write that logic in the body of the for expression. So in that case, it will not be a iterator guard. So let's see what will be the, I'll just say if I dot underscore 3 is greater than 30. Now the question is, what will be the output of this expression? Will it will it be same as will it be same as the previous output, or there will be something different? What shall be the output? The only change I'm doing here is, instead of having the iterator guard, if you write inside the for expression, it is an iterator guard. If you write the same logic in the body of the for expression, it is no more a iterator guard, it is an if else expression. It is an if else expression. Now what will be the output of this? Any guess on that?
It's not returning anything.
It should return, because probably you might have missed the yield keyword. Oh, sorry, my mistake. My mistake. If this is the case, I have to return I. Sorry, my mistake. I did not return I.
Yeah. So then it is same.
It should not be same. It should not be same, because we have learned that if else expression, we did not specify the else here. So if the condition fails, we know that it will return unit. So it should be, so as you can see here, the first return, we had age as 24. For 24, the condition failed. The if condition failed, so it went to the else part, but there was no else at all. Hence nothing was returned. If nothing was returned, unit is the return data type, and unit is represented in this fashion. And the tuple is here. So you have to be a bit careful whenever we use a if else expression in a for loop. I mean for with yield, whenever you use a if else expression. It's better to always use a if and else always. Otherwise you will end up getting such kind of a result. So I hope that was clear.
So,
Yes.
sorry, Pramod. Pramod, just a quick question. So now that we have this as a return array, right, where we have a unit and the other two records, so can I still refer to this unit using like I dot uh, underscore one or something like that, or it is not accessible?
It is accessible. I mean, name, age of 0 would give you this. It's an array. We are accessing the elements of the array using the index.
Gotcha. Okay. Thanks.
Just a second. Yeah, these are all the for loops that I wanted to discuss here. So you can go through this nested iterator, like a for loop inside a for loop. This is how we achieve it. We don't have to write two for loops. A single for loop is good enough. So for every value of x from 1 to 2, it will iterate from 1 to 3. For every value of, that's how we write a nested iterator. There is something called as value binding also. Like we have value binding in match expression, here also we call it as a value binding. We just assign a value here, that's all. We don't need to, for simple expression, we need not write a body of the for expression and then assign some values. That also can be done, but this is also fine. This is also fine. Anything we can do. Any logic. I mean, sorry. So I have looping from 1 to 8. I'm giving the logic here itself. Not much difference here. This one and the same. We are just incrementing by 1. So I can do the same thing in the body also. I need not specify these things here. Not much difference here. So I can just say, but only thing is I have to define val inc equal to I plus 1. And then I have to return I. I have to return I. Because the last expression should not be a assignment expression. The same thing I'm achieving with the body of the for loop. If it is a simple expression, I can just write it in the for expression itself. In that case, we call it as value binding. So these are all the simple things that we have to understand about the for loop. Slightly different from the normal traditional way of doing that. The syntax is different. The way we loop is different. The way we handle the numerical looping is different. The way we return value from the for expression is different. These are the things we need to keep in mind when we have to work with the for expression. Next what I have is while and do while. Yeah, here is a question. The question is how do we decide to return vector or a sequence? Usually what happens, we saw the for loop. We saw the for loop. It takes a collection and it returns one more collection. So we saw this. The question here is, how do we decide whether we have to return a vector or a sequence? Some sequence is a high level, a parent of uh, all the collections. Now, if your input is an array, here also you will get an array. The return, we don't control on that. If your input is vector collection, your output will also be a vector collection. If your input is a list collection, your output will be a list collection. If your input is a sequence, your output will also be sequence. We don't control what will be the output collection. Once we have it, on this we can, there is a method called to vector something. We can convert it. I mean to say, or to list, we can convert in that fashion. If you remember, if you see age, if you see here, I had a collection employees. Employees was an array. Employees was an array. When I did a looping on that, I got name and age. Again, name and age is also an array. You can see that. But I can convert name and age to to list. It should be valid. So we can convert all these things. There are methods available. It's not a kind of a typecasting. All these are methods. Yes, I shall be discussing. The question here is there any difference in those types of collection? Yeah, there is a difference, and I shall be discussing when we talk about collections. I haven't started with the collections, but we will come there as well. So while loop, we will not discuss while loop because it's same as other programming language. You can just go through these examples. We have where x is equal to 10, while x greater than 1, I can do x minus 1 and do some logic here. So this is how we do a while loop, and do while also is there. While and do while. You can go through the examples. Not much any difference like we have it in the. Here is a question: why is the result vector is different between two examples? No. I didn't get the question. Where it is different? The result vector. Why is it- Oh, my mistake, my mistake. Because I am, I don't know why I did that. I had to return increment value. I did not return the incremented value. My mistake, sorry. I just returned I only. So if you see here, it was my mistake, sorry for that. I was supposed to return the incremented value. So now next we have functions. Next we have functions. So what are the way you define a function is simple. You use the def keyword and you give a name to your function as usual. We pass the parameters and we need to specify the data type of the parameters, and I always said that the data type always comes at the last. I will pass one more parameter y and its data type is also int, and the function name and parameters is separated from the body using a equal to sign. I can just say x star y. Body again we can imagine it just like a block of expression. Body is nothing but a block of expression. If you have a assignment expression as the last expression, nothing will be returned from the function. If it is not an assignment expression, if the last expression is not an assignment expression, then that expression will be evaluated, and whatever value we get, that value will be returned from that function. So this is how a simple function is defined. Yes, here def is the keyword. Here def is the keyword we need to use to define a function. So this I have defined a product function, which takes two input parameters or two integer input parameters, and it returns a multiplication of those two input parameters. And we know that multiplication of two integers is always an integer, hence the return data type is integer. We don't have to explicitly specify the return data type. The return data type is automatically inferred by the compiler. So I can call this function as traditionally we used to call other programming languages. In a similar fashion, we can be calling the product. So we can have val result is equal to product of 5, comma. So that's the simplest way to define a function. That's all. Much simplest way to define it. If you want, you can specify the return data type also. As I said, the data type always comes at the last. I can explicitly specify the return data type also while defining the function, even though it is not required. It's not mandatory. Return data type is always optional. And also, this equal to signifies that we are trying to return some value. We are trying to return some value from the function. We can also skip the return type. Sorry, we can also skip the equal to sign. So in that case, we should not return anything. In that case, we should not return anything. So this gives a compilation error. The only thing is what we have to do is I can just say val m is equal to so the if you can remove equal to sign also, it's not mandatory. What it signifies is that means we are not returning anything from that function. Hence the function's return type will be unit. The equal to sign becomes mandatory, not mandatory. I mean, equal to sign is used to signify that we want to return something, Without equal to sign, it means that we are not returning anything. But we can also put the equal to sign there also. Here also we can specify. Both are fine. This syntax is also fine. This syntax is also fine. You don't have to. I mean, you can always use the equal to sign to keep it compatible or not compatible, to be more readable, or even in your coding, you can always use the equal. You can just remember that equal to sign is used to separate the body of the function and the function name or the parameters of the function. So that's how you define a function. Now there are some more jargons here. Again, the jargons, as I said, boils down to again mutability and immutability. We talked about expression, and we talked about statements. Expression is a unit of code that returns value. Statement does not return value. Obviously, in a similar fashion, we have functions, just a name. Function return value, function return value. Here we call it as procedures. Procedures does not return any value. So all these jargons, what they mean? It means here as immutability, and here we mean as immutability. That's all. So that's what we mean by mutability and immutability. So you can have a log function. We can define a function. I can say log or something. It takes an input, a string. I can define a function like this. I can define a function which takes a string, and I will just print that message. Whatever message I send, I just print it. So as you can see here, we are not returning anything because the last expression in the body of the logger function is a println, and we saw that println does not return anything. It modifies the console. Hence, the return data type of logger function is also unit. As a result, such functions we can call it as procedures. I mean, we need not remember these all jargons or not. Remembering is not so useful. We just need to know that whenever what we want to do mutability, or whether we want to do immutability. That's all matters. Write a function for doing mutability, write a separate function for doing immutability. But they have given a jargon called as a procedure. That's all. You can clearly see that the return data type is unit. So we can have a function with empty parenthesis. In that case, I can call the function in this fashion, or I can call the function without the empty parenthesis also. So if you define a function which does not take any input, the function name is something like greet. The body of the function, I will just say hello Scala. The function does not take any parameters, but it returns a string, hello Scala string. So usually I call the function in this fashion, but we can also call without the parameters. That's what they want. These are all the syntax just to remember, not no much concept to learn here. Function invocation with a block of expression. So this is a bit interesting. You can test it. So I have a function called format euro. It takes a simple function. The function name is format euro, means we are trying to do some formatting. We specify the amount. The double is the input parameter. We know when we use f prefix, it is used for string interpolation, or we can say some formatting. How we are formatting? Dollar amount will evaluate the value. Percentage to f will print only up to 2 decimal point, and we are having a pound symbol here just to represent the amount. The traditional way of calling this function, what is the traditional way of calling? I can just specify some input. It will only give us the result up to 2 decimal points, and it says a font. Now this is the traditional way of defining a function. This is the traditional way of calling a function. We can also call a function with a block of expression. We can also call a function with a block of expression or expression block. So we can just specify a block of expression. This is how I specify block of expression, right? Inside the parenthesis. I can write any expression here. I can just say val rate is equal to then point something then. So if you are writing multiple expression on the same line, then we require a semicolon. Otherwise, we don't require a semicolon. If I can just say, so I'm calling this function by block of expression. Now what happens here is this expression gets evaluated. After evaluating this expression, whatever value we get, that value will be returned from this block of expression. That value will be returned from this block of expression, and it will be passed as an input parameter to this function. The return value from this block of expression will be passed as input parameter to this function. So this is how you can call a function with a block of expression. So we had rate is equal to 10 point something, then we added 5 to that, around we got 16. So 16 was given as a input parameter just like this, and it returned the formatted values. One thing I did not discuss is, if I specify this is one expression, this is one more expression. So if you write both the expression in a single line, only then we need a semicolon. Otherwise, semicolon is not required at all. If you write multiple expressions on the same line, only then we need semicolon is required in that case. Otherwise, semicolon is optional. Slash n or the next line is always treated as the end of the expression. End of the Now there is one question. Now if I have rate2 equal to something like this. I have just included one more here, one more expression in our block of expression. In our block of expression, we are including one more expression. Now, what will be the result of this? Any guess what will be the? It is as good as saying. I mean, it may be confusing if I write it on the same line. What I will do is I will say val. I will say rate plus 5 point something. Then I will say val rate2 is equal to something. Now this is a block of expression. Now this is a block of expression. Now what will be the result of this?
So it didn't return anything. It's a unit. It returns a unit.
Correct. That's how. If you see, this is a block of expression, and in the block of expression, the last expression is an assignment expression. Since it is an assignment expression, nothing gets returned from this block of expression. Since nothing gets returns from this block of expression, unit is the return data type. But what we have defined this function to take as an input, we have to pass double value as the input parameter, but the return value is passed as an input to this function. As I said, the return value from this block of expression will be passed as an input to this function. So we are trying to give a unit to this function, but it is defined to accept a double. So there is a mismatch in the data type. This will not work here. It will give a error. It will give a error. So you can see that it says error type mismatch, return data type. I mean required is double, but we were trying to pass unit because our return data type was unit. So we have to be a bit careful on such stuffs where we want to return something and what we want to not return. Whether we want to return something or we want to modify something. If it is an assignment expression, nothing will be returned from the function. If it is not an assignment expression, the last expression evaluated value will be returned from the function. It is just a block of expression. So I hope the problem was clear here.
Pramod, a quick question. So if we have to convert for a dollar instead of euro, how do we do that?
Uh, dollar to euro. Let me check. I haven't tried that. There may be some trick. So because let me check whether I can use invalid string is equal to $2. Invalid. I need to check. I mean, I'm not sure how to escape it because it will try to, because dollar itself means it is used to evaluate. So I need to check how to escape that and get the literal meaning of dollar.
Okay,
Because,
sure, no problem.
yeah, I will check it. Probably I will send a mail on that once I get the solution. A recursive function may not be required. I mean, it's very rare that we use a recursive function. It is again calling the same function again and again. These things may not be required. Nested function also may not be required. It is as usual defining a function inside a function. We just define a function inside the function. So calling the function with parameters may also not be required here. So usually you define a function and this is how you call the function. But we can also call the function by specifying to which parameter we are assigning the value. You can explicitly specify the parameters. So what I meant is, so if I have a function define greet, it takes two parameters, a as string, b also as string, and I can say just return a concatenated concatenate with some space and concatenate with b. So if I have a simple function, the traditional way of calling this function is nothing but first parameter I will say hello, second parameter I will say Scala something. So it returns hello Scala by using our function, using the concatenation. So you can also say, in this case, hello will be mapped to a parameter, Scala will be mapped to parametric. But we can also specify like the parameter name itself equal to, we can just specify Scala a equal to hello. So that is also fine. This is also fine.
This is something default value.
Right. I mean, this is what is used to have a default value.
Okay.
This syntax is used to achieve the default value for a parameter. So we can use the default values, parameters with the default value. The same syntax is being used to specify a default value for your thing. So what we can say here is, while defining a function itself, while defining a function, I can just say the default value for second parameter is this. And that's the, so this is how I'm defining a function where I'm specifying the default value as Scala. The second parameter default value will be always Scala. So I need not pass a value for the second parameter. It's optional now. I can just say hello. I can just say hello here. It will take the, if I don't specify the second parameter, it will take the second parameter as Scala. But we can always override that and specify something else. So the default value will be overridden by the value specified by us. So we can have this. Now, what will be the value of greet if I say B is equal to Java? So again, it will give an error because we did not specify the first parameter. If we did not specify the first parameter, it will give an error that not enough.
Pramod,
Yes.
I have two questions. So does this scalar programming doesn't support method overriding?
Method overriding, it's there. So that will
Because
learn as we go
so
on. Sorry, go ahead.
the second, like greet b equal to Java, so does it not consider as a one more new method with only one single parameter?
Right. In that case, we have to define that function. We haven't defined any such function.
Okay.
We have defined only a function with two parameters. We can define a function with multiple parameters. That we'll see as we go with the object-oriented part of Scala, where inside the class we'll be having multiple methods. Each method will be having different. Just like this, I can say uh, class something simple. I can define greet string b as string, and I'm just concatenating a plus some space here, and I will define one more greet. In this case, it will only take so in that case the definition is nothing but hello. So this is fine. When you define inside a method, I have two different methods defined. So I can call both the methods now. I can say greet I can specify in this fashion, or I can just specify both. So I hope this was your question, right?
Yes, Pramod. Thank you.
Yeah. So these things again we will go be seeing when we learn the object-oriented part of the. Only thing is we need to have that definition of both the function, then we can always use the method overriding. So we can also have a variable number of arguments. So I want to define a function which can take any number of arguments. It can take no arguments, it can take one argument, it can take two arguments, or it can take any number of arguments. So to achieve that, we just use a star symbol at the end of the data type. We just need to use that. In that case, items is treated as an iterator. Items are treated as a iterator or a collection.
But the argument should be of the same type, right?
The data type should be of the same type, right? Usually it should be the same type. So here I'm specifying integer, so you can only pass an integer. You can only pass an integer, and this will be treated as a collection. The input parameter will be treated as a collection of those all input parameters, and we can loop on that collection, and we can do some operations as we are doing a multiplication operation.
Suppose if you want to send the heterogeneous data types, then we can define it as any, right? Any star.
We can specify any, but the compiler won't know what is the actual data type. We can do that. We can do that, but instead of that, it is better to take it as a there is one more generics. Like in Java, we have Java generics. Here also the same thing is available. Here we call it as a type parameters. We usually use type parameters for achieving such stuff. We will see. We will go ahead and see how we can achieve that. Any could also be used, but it is not preferred as the compiler won't be knowing what is the individual data type. Again, every time we have to, if any operations you are trying to do, you have to check whether it is an instance of integer, do some operation. Whether the second element is an instance of string, again check it and do some operation. So the compiler won't be knowing the individual data type in that case. We will be seeing those examples going forward. So the way I call this function is I need not pass any parameter. Star means you can pass 0 or any number of parameters. Similarly, I can pass only one parameter, or I can pass two parameters, or I can pass any number of parameters. Any number of parameters. So it will just, this whole thing is being passed as an input, hence that input parameter name is items. Items will be treated as a collection here. It will go through each element of the collection here, and we are just adding all the elements. So that's how we achieve the input data. Sorry, my mistake. That's how we achieve variable number of arguments, and the data type should be same. There is one more thing. I mean, this parametric groups. So this is a. I mean, there is no new concept here. No new concept here. Only thing is the syntax is a bit different. The syntax is a bit different. And the use case we will see later, because since there is no concept behind that, the syntax is used to for other purpose, and to understand that we need to learn some more things. So we know that traditionally how we define a function. The traditional way of defining a function is this is a traditional way of defining a function. Def keyword, function name, parameters, and equal to sign to separate, and the body of the function. Since I am having only one expression, I need not require parenthesis. Sorry, open flower bracket and close flower bracket is not required. So traditional way of calling this function is in this fashion. Now Scala also gives us an option to define a function in a slightly different manner, and it is called parametric groups. The way we define a function is, I can define a function. This is one parametric group. This is one more parametric group. So in first parametric group, I can have any number of parameters. In second parametric group also, I can have any number of parameters. The definition remains the same. Only thing is the input parameters are different. The syntax of specifying the input parameters is different. This is called parametric group. This is one parametric group. This is one more parametric. So the way we call this function is in this fashion. This is how you call a function. Usually we call a function in this fashion. Here this is first parameter group, this is second parameter. I mean, as I said, there is no concept behind that. There is no concept to learn why we are having a multiple parameter group. Only thing is the syntax is being used. You can
So
have
what if we try to send 4,5?
sorry.
No, if we give pass product of 4,5.
No, that's what we. Oh, you are saying 4,5.
Yeah, 4,5. Yeah. So what it will throw any error?
Right.
Okay.
The
So when it will be useful?
right. That's
This
the
kind
one
of
I wanted to discuss. As there is no concept behind this, the only use case is the syntax. The only use case is the syntax, and these syntaxes are used in higher order functions. It is called parameter groups, or it is also called as currying. The syntax is used in higher order function and implicit functions, implicit definitions. So to understand how it is used, we have to learn higher order functions and we have to learn implicit definitions. Only then we will be able to understand this parameter groups. But as of now, what you can imagine is certain parameters have same behavior. You group it in one group. Certain other parameters have their own behavior. You group those parameters in some other group. Just like I can just say, I can redefine this function and I can say, so as of now you can just imagine that all integers are grouped in one group, all doubles are grouped in another group. So that's the only use case I saw with the parameter groups or currying. Only the syntax is used, and we can use those. You can imagine, as of now, you can just imagine that certain parameters have certain similar properties. They are grouped in one group. Some other parameters have their own similar properties, so they will be grouped in another group. So that's how we can imagine. But we will see more of a syntax use case when we learn higher order functions and implicit parameters. So we can just say 4,5, and the second parameter group takes 2 point something 5. So that's the parameter groups or currying. That's the parameter group or currying. Just hold on to that thoughts. We will come back to these parameters groups again when we learn higher order functions and implicit parameters. So next what we have? Next we have type parameters. Type parameters are nothing but uh, generics. Like we have Java generics, here we have type parameters. So let's understand what is a type parameter here. So let's say I define a function called identity. I define a function called identity. It takes a string and I'm just returning that string. I'm not doing anything. Just take the input and just return the input. That's all. It takes a string and just returns a string. So if I call this function with something, hello Scala, it will just return hello Scala. Now can I pass this function 10? Can I pass an integer to this function? We know that this function expects a string. String is required, but if you pass an integer, obviously it will give an error. You cannot pass an integer if it is expecting a string. Similarly, I cannot pass a double when it is expecting a string. In a similar fashion, I cannot pass a boolean when it is expecting a string. Now this function is restricted only for string. Now how can I make this function a generic function? I mean, it should be able to accept any data type. It should not just be expecting string. It should be able to accept integer, double, boolean, or anything. So this is where you use the type parameters. We use the type parameters. You define, so the way you define the syntax is in this fashion. I'll just say define identity. The type parameters, I will say t here, and I will say yes. S will be of type t, and just return. Now we can dynamically pass any value for this parameter. So we can just specify identity. We can say it is when we say it is integer, type t is now int, and we can pass 10 here.
So it's same like generics.
Right, it is generics. I can specify double and we can specify 10.5. I can specify string here and I can say any string. So this function we have made it as more generic. This function has become more and more generic. Int, it can take an integer, it can take a double, it can take a string, it can take a boolean, it can take any user defined class as well. It can take any data type specified. So it is a generic here. So to understand, I mean, so it is called as type parameter. These are called as, t is called as a type parameter. I mean, it is only it is not a rule that it has to be capital. It's for the convenience purpose. It's for the convenience purpose you define it as in the capital letters. Otherwise we get confused with the normal parameters. You can define in this fashion also. It need not be a capital. I can just say, but again it creates a lot of confusion how to differentiate between normal parameters and the type of parameters. So what we are trying to say is to remember this type parameters. So I just want to give an example. We have a product. I have defined a function called product, x as int, y as int, and I'm just saying x star y. Now I call x y as value parameters, because we pass values for these parameters. Hence I call them as value parameters. Whenever we call this function, we pass values 4 and 5. Whenever I call this function, I pass values 10, 20, something like this. We can pass different values. Dynamically, we are assigning different values for these parameters here. Hence, we call it as value parameters. In a similar fashion, we pass the type also in a dynamic fashion. Like x is defined as a type parameter, sorry, x is defined as a value parameter, t is defined as or is called as type parameter. Means type also can be passed dynamically while calling the function. You can, in a dynamic fashion, we can specify t, we can pass integer for t, we can pass string for t, we can pass double for t. These are the values for this type parameters, for this t. Like 4 and 5 are the values for x and y, double, int, string are the values for this type t. Hence it is called as type parameters. So you can remember in this fashion. We are dynamically passing the data type while calling the function here. Going forward, we'll be using more and more, because Scala has lot of APIs which are type parameterized. In Spark also there are a lot of APIs which are type parameterized. I mean, most of the time we'll use these already defined type parameterized APIs, or you may also write your own function which is type parameterized. So mainly whenever you are writing a library, or whenever we are writing a framework, that the APIs that are exposed through that library, or the APIs that are exposed through that framework, those APIs should be very generic APIs. We shall be exposing that APIs to some other team or to the client. So that APIs has to be very generic. In that case, we use the type parameters. We will be looking more and more into these stuffs. So let's say I define a function called simple box, or I will just say product. It takes two different type parameters, a and b. It takes two different type parameters, a and b, or it takes the same type parameters, a. X I will say as a. Y is also of the type a. If x is integer, y will also be integer. That's what we mean by both are of type a. So now can I say x star y? Will this work here?
No.
Right. So it will not work. Any reason why it will not work?
So it can be a string type. String cannot be multiplied, or any other like Boolean.
Correct. Correct. String could be multiplied, but as you said, it's correct. The compiler as of now doesn't know what is the type of x and y, whether it could be integer or it could be some our class that I have defined. If you remember, uh, for to so it could be this, an object of this. Because it's type A, I can pass any object there. Not necessary that I have to pass only integer object. Not necessary that I have to pass only string object. I can pass any object there. I can pass any object there. So I can pass this also. But in this class, there is no star method available. There is no star method available. Hence, it will not compile at all because the compiler doesn't know what objects you will be passing, whether the star method will be available in that object. Star method will be available in that object. Now, how can we solve such a thing? So we can solve such a thing by making it as we pass any value which shall be, I don't remember the, I can just say as int. So what this syntax means here is you can pass any data type A if it is a subtype of integer. You can only pass those things which is subtype of integer. I cannot say any value also, I think. Because under any value, we don't have, there is unit also is there. There is a boolean is also there. Boolean does not have x star y. So this way also we can achieve the things. The syntax means that you can only pass those parameters whose data type is a subtype of integer. Since integer has a star method, any subtype of integer will also have a star method. So this way we can specify. So this will work fine. Double will also work fine. But this is not, we can also define in some other fashion also. We can just say we don't know the data type of x and y. Programmatically, we can determine the data type of x and y. We can use a match expression here, x comma y. We can say x comma y can be, this tuple can be passed to the match expression. This tuple can be passed to the match expression, and we can have a case, do a value binding here to a, specify int b as int. Now we know that if this pattern matches, then a and b are integer. I can just say a star b. What happened here?
It is equal to greater than.
Okay.
Equal to greater than a star b.
My mistake. So this is the syntax, and I can also say that if it, I can have all the different combination also. If this is also fine, this is also fine. If such is the case, I can do all these operations. Case anything else, we can just say something. Just return an integer. Something I will just return. So in this fashion also, I can do this. A not found. Why did it found? Oh, I did not define that type parameter. My mistake. So I have to specify type parameters as A, match this. If case is this, So this will work. Using
You haven't mentioned the default
a default, I mean,
case class.
it may not be required. It may not be
Okay.
required. I mean, it will obviously it will give an error if I pass a string. You will get a runtime error. So here we get the error at the runtime. If you try to define in this fashion, you will get the error at the runtime. It may not be so safe. But if you define a function in this fashion, in another way, if you define a function in this fashion, you get an error at the compile time itself. This is more safer. Defining a function in this fashion is more safer because your errors will be caught at the compile time. But in this case, if you try to pass a string, you'll get an error at the runtime. This may not be much safer way of defining a function. This would have been a much safer way of defining a function. So I hope the type parameters are clear here. How these are called as upper bounds and lower bounds. So this means that you can pass those data types which are integer and which are subtype of integer class. This syntax means. So you can also say whichever is a, you can, if I mean this. This means you can pass those data types which are supertype of integer class, which is a parent class of a integer class, including the integer class. You can pass an integer and also you can pass an object of the superclass of the integer also. So these are all the syntax that we need to remember whenever we are using such kind of a type parameters. Going forward, we'll be seeing more on this as we understand more and more about the functions. So these are the basic types related to generics here, Scala generics. So methods and operators we have already seen. As I said, there does not exist any operator at all. Everything is a method inside a class. Yeah, here is a question. The question is to just explain what is the lower bound and the upper bound. Now this syntax is used as a lower bound. The syntax less than. You can just take this less than and you can, we always know that that symbol always represents less than. So we are saying whatever type we want to pass as a parameter, that type should be a subtype of integer, or it could be an integer class, integer or subtype
So,
of integer. Now you
so
can,
now we don't have any subtype for integer, right? Like is
right,
short or byte.
right, we don't have. It also means
But the
that you
super
can,
type,
right,
also we cannot say a double or float as a super type, right? For int.
right. It is not. We cannot pass double or, so that's what. If I try to include,
Even long is not a super type. Only the any value is the super type.
any value is the super type, but if I include any value, if I include any value, it will also include unit. It will
Correct.
also include character, boolean,
Boolean.
all this stuff. Short and byte are kind of a subtype. So I can say
Oh,
double.
short.
I can include
Oh,
double here. So
right.
that is not the correct way. I can just say double. expected.
So if we define upper bound and we can give a double value, right?
Much better is x is of type A, y is of type B. And I can just say x star y.
Now we can pass a double, float, a long, int, everything.
Right. We can specify 5, 6.
Oh, we have to pass the data type, right?
We have to pass the type
Int,
mismatch.
int, float. Okay, it's int.
I should see what is this actually. It may not be the.
It's a integer type.
I know. I don't think so. It is a subtype of integer. Integer. I don't. This arrow mark may be some. It means
Oh,
something different.
okay. Something it inherits, but it's not a direct
Right.
subtype.
It could be. So there is one more way. I will just come out. I don't remember that. You can specify that only those parameters you can pass which has a star method. So like we are saying, we can only pass the parameters which is a subtype of double. In a similar fashion, I can only pass those parameters which has a star method. So that also we can specify here. I don't remember. I will just come up with that syntax and I will send a mail on that. So that would be much better because in that case we can have integer, double, short, byte, everything can be included in that case.
So when do we actually use this one?
I don't think so. Double is the good example here. We may have our own class. You
Yeah.
define your own class, and your function should always take a object of that class or a
Yeah.
object of the subtype of that class. Just say, just say for example, a serialization and
So we can
deserialization.
we can give a triad and then we can have subclasses which extend the triads, right?
Right. Usually the use case is one of the use case that I have come across is serialization. You define a template for the serialization and your function will only take subtypes of the serialization. You want to do integer serialization, you want to do double serialization, you want to do string serialization or some other serialization. We will see the use case how these type parameters are being used. But this is what I want to give as a simple type expression. So here we can specify product something like this. You can also define something that I want to only pass such objects which has star method. So I will just Google that. You can also Google that, but I will try to send you the. So that's how we use the type parameters or how we use the generic types. Oh, I think I diverted from Mohan's question here. Mohan, was it clear? Like this syntax means you can always. This is the lower bound. Sorry, this is the upper bound. Double is the upper bound. You cannot pass anything which is a superclass of double. Now double has been treated as a upper bound. In a similar fashion, if I define something like this, it is greater than. Anything that is greater than double means any class which is a superclass of double can be passed as a parameter to this. But if you pass that, there may not be any star method, this will not compile.
So here the symbol colon less than and colon greater than is the lower bound and upper bound, right? Defines.
Correct. These are the lower bound. This is upper bound, and this is the lower bound.
No, that is the lower bound, right? So less than colon, which means less equal to or less than or equal to that one.
Right. You can
And
pass
colon
anything.
greater than is.
You can pass anything which is subtype of double or it is double.
Oh, which means upper bound.
Right. Double is here the up. I mean, you can look it in any fashion. A will be treated from, if you look from the A's perspective, it is lower. If you look from the double perspective, that's the upper bound. You cannot pass anything more than that. I mean, we can treat it in any way. In this case, you cannot pass anything which is less than double. Double could be treated as the lower bound here, or we can just say A is an upper of the double. Anything that is a superclass of double can be passed. But this will not compile because anything that is a superclass of double may not have a star method. It will not compile. Is this the syntax or is this the syntax? Okay, that's the only. Right. This is the syntax. My mistake. This is the syntax. So as you can see, this will not compile because star value is not a member of type A. Because anything that is a superclass of double may not have a star method defined in that. Hence it will not compile. Hence it will not compile. So I hope these things were clear. Again, we will be using.
You can safely put a plus sign, right? X plus Y, which can be applied for any type.
No, it plus also may not be.
Unit will not be.
No, anything that is you can pass. What we are saying here is we can pass anything which is a superclass of
Double.
The superclass of double could be any value or it could be any. Any may not have a plus method defined in that. Any value also may not have a plus method defined in that. So it will also not work.
Right.
So such are the things. So we have to be careful. I mean, all these things you will come across whenever you are writing your own APIs. I mean, you define a class and you define certain methods and you want only certain objects to be passed to that methods so that you catch the errors at the compile time itself. Most of the errors can be caught at the compile time itself. If that is not happening, then your API is not so safe. At the runtime you can get any errors. If you are passing any object, those object operation may not be available there. So you can get any runtime error, which is not a good thing. So all these type parameters, lower bound and upper bound, the main reason they exist is to catch all the errors, most of the errors at the compile time itself. You restrict sending some data. You only restrict to certain objects you can send. You cannot send every object as a parameter. So when you restrict at the compile time itself, it is good because you achieve a lot of safety here. I hope the overall idea of type parameters was clear. Why type parameters actually? One is generic, that you can pass any number of any different data types, and whenever you want to restrict, you use the upper bounds and the lower bounds.
Pramod,
Yes, Kala.
can we have a set of types? Like I want to pass only int, short, and double, only these three.
Only these three.
Like in the first one, it is like in the first example you have given, any data type can be passed.
Correct.
And in these lower bounds and upper bounds, you are fixing either the boundaries.
Correct. The same boundaries, you want it for only integer, short, and byte, right?
Integer, short, and double. What are any three data types?
Okay.
Or else integer, double, and string, where all these three have the plus method.
Okay. Yeah. I will. I need to check how do we pass that. The one way to do that is pass only those objects which has plus method. Such kind of things can also be done. So you can search that as well.
And also, do we have any range option here instead of having a boundaries?
Right. I mean, both the things could be used, which is a super type of this and a subtype of that. Like
Okay.
I don't have a concrete example. I can come up with one. So you can have any value, this, a, and something like this. Any and double, something like this. Your type
Okay.
could be something. So from this range to this range, you have to use those symbols. That's all. I will come up with an example with that as well, but with only plus method. I it is giving the Java. I think I will check that. We will check that.
Okay. Yeah.
Both the
Thank you.
examples I will send one side. I will go through that and I will send the examples. So next I will try to give an introduction here. This is a bit complex now. Whatever we have seen now is a bit of a basics to intermediate. Next, whatever we'll be seeing is slightly more than that. Will be slightly more than that. So here functions are called first class citizen. Functions are called first class citizen in Scala. So what do we mean by that? We can have any jargons, first class citizen, anything. But now, what do we mean by that? The meaning is the way we use identifiers, the normal operation that we do, the way we use an object. This is how we normally do the basic operation. We use object, we do some operations. Functions can also be used in the same fashion. The way the basic types are used in a language, if the functions can also be, I mean, functions could also be used in a similar fashion only. So that's where we call it as a first class citizens. So functions can also be, it means functions can also be treated as an object. So that also comes from one more perspective, saying Scala is a pure object-oriented program. When we say pure, we mean that anything that we create is an object. Anything that we create is an object. Even the function that we have created is an object. Functions are also objects. That's what we mean by pure. Anything that is created is an object. So here we define multiple functions, right? These are all objects. Product is an object. Whatever functions I have defined, all those are internally an object. So since you can have functions as an object, whatever we can do with objects, the same things we can do with the functions also. Just like what I can say is we can assign a value to an object. That is val x is equal to 10. We are assigning a value to an object. We can say assign a, an object to another object. We can say val y is equal to x. We can pass an object as a parameter to a function. We can return an object from a function. All these things we can do, just like we had the product function, right? X and y are the parameters. Here also we have the product, x and y as the parameters. The return is also an object. The multiplied value which creates an object, and that object is returned. In this case, these two, in this case. All these things we can do with the object. Now we said that functions are also object because that's how the Scala internally treats them. The functions are also treated as object. So what we can say is we can assign a value to a function object. We can assign a function object to another function object. We can pass a function as a parameter to another function. We can return a function from a function. So all these things can be achieved because Scala treats a function as an object, and hence they are called as first-class citizens. Now what is the use of having all those stuffs? Why do we want to treat a function as an object? One of the use cases is this. Especially this use case is used in more of a Spark. This is one of the use case. You can pass a function as a parameter to another function because it is as good as passing some object. So those things we will see later. This is the introduction I wanted to give. What is a first-class citizen? It's all about Scala as a pure object-oriented program. Everything is an object here. So we can pass a function as also as a object as a parameter to another function. Mainly we'll be concentrating on this part where we can pass another function as a parameter to some other function. So those things are called as function objects. We usually call it as a function object. First we'll see how to define a function object, because the syntax we need to learn. We need to learn the syntax of creating a function object. Later we'll see how that function object can be passed as a parameter to another function. So that's our main goal. So we'll wind up the session here, because that we will be starting with a new concept, and I would like to go with a fresh mind with that. So I hope we will wind up the session here, and let's continue tomorrow. Thanks everybody. Good night and have a nice day. Let's
Thanks,
continue.
Pramod. Have a good night.
Thanks, Pramod.
Thank you.
Thank you.